Hey y'all! I hope that the homework isn't giving you too many problems and that you feel ready to learn some new concepts. We are starting today with the intermediate value theorem, which is super easy to understand conceptually. In order for me to actually be 5'4", at some point I had to have been 4'8". That is the general concept of intermediate value theorem. Another idea behind the intermediate value theorem, it's not just height. Let me think about this. Any kind of measurement. So in order for the rain gauge to say, 2 inches, at some point the rain gauge said 1 inch. That's all, conceptually, that's all there is behind it. And we're talking about measurement or some sort of continuous function. Okay, so now I'm going to read this page to you. And I'm doing this more for me than for you because I assume you can read. It just helps me get my bearings to read it out loud. Since a parent's height is a continuous function of time, if a child had a height of 58 inches at age 11 and a height of 64 inches at age 14, then the child's height took on every value between 58 inches and 64 inches for some time between the age of 11 and the age of 14. This is a simple example of an important theorem in calculus called the intermediate value theorem. So, the intermediate value theorem states that if the function f is continuous on a closed interval from a to b, and those two endpoints have y values that are not the same, and there is some y value between those aforementioned y values, then there exists some x value, a and b, for which f of c equals k. Okay, so what does that look like? No matter what kind of squiggliness you have going on between the x value a and the x value b, or you could think of it as the y value f of a and the y value f of b, no matter what kind of squiggliness is going on, it could even be crazy squiggly. No matter what, every single y value between, even if it's this crazy looking, every single y value between f of a and f of b must have been along that curve somewhere. That's what it means. It doesn't matter where you pick it. So right here, pick a y value. Pick a y value. Look. Oh my gosh. It actually crosses, more than once. But it definitely crosses once. Pick any y value along there between f of a and f of b, and you'll see that no matter what y value you pick, that function, that crazy kooky curvy function, goes through it at some point. That's all it's saying. Okay, so this example at the bottom of the page is actually going to be on the next page. So what you end up knowing is that it takes on this y value, and you are going to be finding the x value most of the time, if I remember correctly. I only teach this once a year, Uh-oh, did I go too far? No, I didn't. Where's the top of it? Oh, okay, you can see it, I couldn't see it. Okay, given the following function, determine the intermediate value theorem. Determine if the intermediate value theorem holds for the given value of k. If the theorem holds, find a number c for which f of c equals k. If the theorem does not hold, give the reason. Draw a sketch of the curve and the line y equals k. I want to first acknowledge that I do these problems backwards. I have to visualize the function before I even begin. So if you are also that way, feel free to do the problem backwards. I guess technically I'm not doing it backwards, but it does. C is where I'm kind of headed with this. But I look at the function. If you can, look it on a graphing calculator or on Desmos. If you only have Desmos, you definitely need a graphing calculator for the AP exam. Hopefully by then we'll be back in the classroom and I can lend you one. So don't stress out about that too much. So we're looking at this function and we're going to determine if the intermediate value theorem holds for the given value of k. In order to do that, you need to determine whether or not the function is continuous on that interval, and it is. We also need to determine that f of a and f of b are different values. And lastly, we need to solve for c. Once we've determined that they are two different values, we can say that b is true, or the second condition for the intermediate value theorem is in fact true. These three little dots, remember, that means therefore. And now we need to solve for c. Now, some people get confused when they see the notation the way that I've written it, so I'm going to rewrite it off to the right for those of you that don't understand what I've done there, using the variable that I've used there. So there we go. I found a value for c, and I have found that f of 6 equals 1/4. And all we have left to do is to graph the line y equals k. And y equals k is super close to the x-axis. And if I had graphed the original function more accurately, you would see an intersection there. I did not graph it very accurately. So there we go. They should cross around there if I had made that curve a little more slanty downy. Okay. So if you're me, if your brain works anything like mine, go back through the directions and make sure that you showed that all three conditions for continuity in fact hold. So we showed that it is continuous. We also showed that f of a does not equal f of b, and we were able to solve for a value of c. We found, in fact, that c is 6, and f of 6 equals 1/4, which is the k value we wanted to solve for. Okay, some of you don't need to do that because some of you are better at following directions. But anyway, moving along. Given the following function, determine if the intermediate value theorem, I'm reading this aloud for me, not for you. Given the following function, determine if the intermediate value theorem holds for the given value of k. If the theorem holds, find a number c for which f of c equals k. If the theorem does not hold, give the reason, draw a sketch of the curve and the line y equals k. So real quick, it is sufficient to simply say that f of x is continuous on -1 to 2. You can assert that if it is true. In this case, it is true because it is a parabola, and parabolas are continuous on their domains. We can also state that the f of a is different than f of b, and from there we go ahead and we try to solve for c using k. Okay, if you are lazy like me, you wait until the last minute to get out your calculator to figure out what these values of x might be. And I have discovered that those two x values could be 7.578 or negative 12.808. So what I am seeing is neither of those x values are in the interval specified. So I'm going to graph this and try to figure out what's going on. And I do have a very important note right here. I want you to notice that in both cases, I rounded to 3 decimals. Anytime you must give a decimal answer, you must also either round or truncate to 3 decimal places. Truncate just means you lob off anything beyond the 3rd decimal place. This does not mean significant figures. It means 3 decimal places. Haha, lying. Sorry. This math is wrong. That, I knew I did something wrong and I couldn't find it. Desmos, you failed me. This number should be 7.808. There we go. And that number is in between -10 and, ooh, what's happening? Uh-oh, y'all, something's happening. And I gotta figure it out because I know that there is a value in between here, a y value, and I can't find it because my calculadoros are messing up. Wait, I should say I don't know how to use a calculadoro. Oh my gosh. If I had the option to back up, I would. That is hilarious. I multiplied wrong. Okay, sorry about that. I'm going to go back in and erase all this booger because that should have been 40, not 400. And that explains it all. So I'll be right back with a cleaner slate. Okay, there we go. So if you look carefully, I knew that I had made a mistake because I had a picture of the graph in my mind and I have circled their point of intersection with a very light oval circle thing. And I knew that this actually had a solution. So I knew that I'd made an error. Sadly, it was not my calculator, it was my brain. I'm sorry. There we go. There is our value of C. And let's see. Let me say the word C one more time in a different way. And if you are not me, be sure you don't accidentally square 10 when you're using the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, real simple math there. I did have to get out a piece of paper because my brain works better with paper, as I'm sure most of yours does too, because that is what we are accustomed to. Moving along. Okay, straight out of the chute, you make sure that f of a does not equal f of b. Verify in your head that f of x is continuous. State on paper that it is continuous on the interval specified. And now go ahead and solve for C. So in this particular case, I went ahead and I solved for my x values, and I did it properly this time. How embarrassing. Anyway, if you look in here, I am not going to actually figure out what those decimals values are. -3 minus about 5 is bigger than -1, divided by 2, I'm sorry, is bigger than -1. And -3 plus about 5 divided by 2 is in the interval. Okay, so I've written this out for those of you who didn't understand what I was saying when I was saying about 5. So we know that the square root of 29 is somewhere between the square root of 25 and the square root of 36. Well, the square root of 25 and the square root of 36 both fall in the interval. So it only stands to reason that the square root of 29 would also give us something in that interval. Now the other one, the -3 minus the square root of 29, is definitely outside of that interval. If you want to verify that with a decimal, you are more than welcome to do that. But these estimation skills are really going to come in handy as you go through this course. They save a lot of time. Now the last thing you're going to want to do is make sure you actually answer the question, which is something that I am terrible about. So we can say therefore, in practice, I'm pretty good as a teacher most of the time. I usually remember to go back and look. So therefore, f of x equal to 4 lies on the interval. Sorry, I keep having to zoom in and out. On the interval -1 is less than or equal to x is less than or equal to 2. Okay, we're going to look at the next one. Okay, in this case, we can only say that it might be in there. We might have something bouncing all over the graph, but it is not necessarily contained in this interval. In other words, f of -1 is less than or equal to 10, but that is not less than or equal to f of 2. And, oops, there we go. Okie dokie. Those are all of the notes that I have for you for the intermediate value theorem for today. I hope that you are having a fabulous weekend, and I will see you Monday.